We will solve this today's LeetCode problem. The question is find the city with the smallest number of neighbors at the threshold distance. So the question is LeetCode medium. Let's see what the question is asking. So we have given n cities from 0 to n minus 1. We have also given an edges array which has given from the source to destination node, and also a weight is given between the edges which representing a bidirectional edge, mean it is a undirected edge, right? And the weighted edge given between source to destination, and a threshold value is given, distance threshold. We will see what is distance threshold. So we need to return the city with the smallest number of cities that are reachable through some path and whose distance is at most distance threshold. So basically we need to return a city number which has which can from there which can reach to the through some path which to smallest numbers of other cities, which is at most distance threshold. So that's the basically the need of distance threshold. That and this weighted edge is representing the distance between 1 to 0 or 1 to 3, like that, right? And if there are multiple such cities, return the city with the greatest number, right? So basically, what we need to do, we need to find out the city number. So the conclusion of the question is we need to find out the city number, and such that from this city number, from this city number, we can we can reach to the uh, the smallest numbers of the cities, right? The smallest number of cities, the smallest number of cities through any path, right? Through any path, through any path. And within what, within the given distance, within the given uh, threshold distance, right? Given threshold distance. And weight is given, weight is representing the age, weight is representing basically here distance between the nodes which is connected, between the nodes which is connected, right? So if we see the first example here, uh, so let's change this appearance, right? So if we see the first example here, so here in this is n is equals to 4, and this is ages, and this is distance threshold, right? So if you see 0 to 1 is a 3. So 1 to 0 distance and 0 to 1 distance is 3, right? And we have given distance threshold 4, right? So 0 to 1 is reachable, right? So we can reach from 0 to 1, we can reach 2. So 0 to 1 3, 1 to 2 3, plus 1 4, and distance threshold is 4. So yeah, we can reach from 0 to 2 also. Can we reach to 0 to 3? 3 plus 1 plus 4 5? No, we can reach. Can we reach to 3? 0 to 1 3, 1 to 3 4, which is 7? No, we can't reach, right? So basically from 0 we can reach to 1 2, right? Similarly from 1, if you see 1 to 2 1, we can reach to 2. 1 to 0, we can reach to 0 also. 1 to 3, we can reach to 3 also, right? So from 1, these nodes can be reachable within this distance threshold, right? Again for same for 2, same for 3, and same for 3, right? These are the four nodes. From 2, this is 3, 1 is also there, and 0 is also reachable, right? For 2, for 3 again, 1 is reachable, 2 is also reachable. So basically, which nodes has the smallest number of cities we can reach? So 0 and 3, which can reach only 0 1 and 3, right? 0 uh, sorry, from 2 we can reach to 0 also, right? We can reach to 0 also, right? So 0 and 3 are the nodes from which we can reach to smallest number of cities, that is number 2, and there are two nodes. But which city should we return? So here we have given, if there are multiple cities, return the city with the greatest number. So answer would be 3, right? That's the question here, right? I hope you understood the question. So basically, if you see, we need to you need to see that we need to find out each and every distance from each and every node to each and every node, right? So basically we need to find find the distance from each node, from each and every node to from each node to every other node, right? That's we need to find the distance. and we will check that whether this distance between any nodes is within the limit of distance threshold or not, right? That's the motto. So basically we need to find the distance, and then we can simply do that. So basically we need to find out, but how we will do that, right? So there is a you can think of like that, like brute force approach, like, because if you see the constant, if we see the constants, they are 100 only. It means if we want to find out from each node to each node, we can find out, right? But for that we need to iterate in each and every node, right? From 0 to 1, then 2, then 3, for each and every node. So there is a very famous algorithm for finding the distance of each node to every another other node. That algorithm is Floyd Warshall algorithm, right? Floyd Floyd Warshall algorithm. What does it says? It says that suppose we need to move from a node from I to j, right? We need to find this between the distance this I and j, and we need to find the minimum distance, right? We need to find the minimum distance, because if you see we can reach 0 to 2 in 0 1 2, like that, 0 1 4 1 3 2, like that also. But minimum distance is what? 3 and 1, which is 4. And from here 0 1 3 2, 3 plus 4 is 7, 7 plus 1 is 8, and 8 plus 1 is 9. So we need to find the minimum distance, right? Which can be in the which can be which is in the inside of distance threshold, right? So 0 1 2 will be the applicable path, because its distance is 4. So for finding the minimum distance, this Floyd Warshall algorithm says that if we take k between k, that if we take a k mediator node, this is an intermediate node, right? It is an intermediate node, right? So basically Floyd Warshall algorithm says that if we need to find the minimum distance between any two nodes, then we need to take we can take our intermediate node, and then we can simply start joining from I to k and k to j between them, right? So if we know the distance between I to if we know the distance between I to k and from k to j, then we can simply know the distance between ij, right? Right, because it's an intermediate node. K is an intermediate node. So if I can find distance between I to k and kj, that is equals to distance ij, right? But k will be anything, right? K will be anything. So k can be k can be anything. So k ranges from 0 to n, right? K can be anything. So basically what we need to do, we need to check for each and every node from 0 to n, such that which distance will be the minimum among all of them, right? Which distance will be among all of them, right? So if you see in this, suppose I need to reach from 3 to 0, right? Suppose I need to reach from 3 to 0, right? So what we need to check that from between 3 to 0, what are the intermediate nodes we can take, right? Between 3 to 0, what can be intermediate nodes we can take? So first thing I can take is itself 0, right? So between 3 to 0 and 0 to 0, 0 to 0, right? What it would be? It would be 3 to 0 is something like that. I don't know, or now I don't know, but I can think of anything, right? I can think of anything. So from 0 to 0, it is must be 0, right? From similar nodes from source to node, it will be 0. But from 3 to 0, I still don't know. So let's take it as a intermax value, right? Let's take it as a intermax value, right? Because there is a no direct edge between 3 to 0, right? So I can also think of 3 to 1, and from 1 to 0, 3 to 1 and 1 to 0. I can also think of 3 to 2 and 2 to 1, right? I can also think of uh, 3 to 3 plus 3 to 2, right? That can be intermediate nodes. All nodes are intermediate nodes, can be possible, right? So among this, the node which is the distance which will be minimum, right? Among this, the distance will be among this, the value which is minimum, which will be minimum, gives me the distance between I and j, and which is distance between 3 and 0, right? 3 and 0, right? So basically, that must be make a 2D matrix, right? It will be make a 2D matrix, and we need to we need to we need to we need to check for each and every node from by taking an intermediate, by taking that node as intermediate, right? Intermediate, right? So we will find that's how we will find that's how we will find that's how we will find the distance between each and each node to every other node, right? Between each node to every other nodes. So after finding, suppose I have find all the algorithms in my distance something, right? In 2D, in distance, this is a distance, right? Right, distance array, right? And we have find all the things. So basically, if we have find all the things, and now what we need to do, we need to check that from each and every node can what are each and every node, the distance between inside this distance threshold, right? So we will again traverse, right? We will again check from each node to every other node, and check that the distance, the minimum distance, right? We have find the minimum distance, right? The minimum distance we have find between the pair of nodes is less than less than or equals to the given distance threshold, right? Given distance threshold distance, right? Given distance threshold distance, right? That should be there, right? And if it is there, we will just count it. We will just count it, and we will count for each and every node, right? And the minimum nodes, the minimum count would the node which has minimum count, the node which has minimum count would be the answer. And if there are multiple nodes which has the minimum count minimum count would be the answer. If there are multiple nodes, then the node whose value is whose value is greater, then will be the our answer. That will be our answer. So main thing is here, that main thing is not here, right? This is anyone can do. Main thing is to think of Floyd Warshall algorithm. So if you need to find distance between each node to every other node, and the constraints are very low, suppose like n is equals to 100 till, right? So you can think of Floyd Warshall algorithm, right? If you need to find the distance between each and every other node to each and every other node, and the constraints are very low, you can definitely can think of Floyd Warshall algorithm. It is always applicable, right? And it is short, and it is a short and good algorithms, right? For finding the distance between each and every other node, right? So basically, what we need to do, we will implement it, and we will see that whether how this is working, right? So suppose the first thing is, so main the Floyd Warshall algorithm says that we take a help of each and every other node to reach to j, so that I can find the minimum distance between I and j. That because in graph, you from reaching from source to destination, there can be possible many paths, right? And we need to always take the minimum distance for it, right? For reaching the its neighbors, right? So for minimum distance, we will take the help of intermediate nodes, basically. That's like that. It's just like a brute force approach. If you think of, if you don't know Floyd Warshall algorithm, if you think of just like a brute force approach, it is just like that. So let's just take example. So first thing is to store all the edges, right? So first thing to note is that we need to take a distance between each another node, right? So the first thing is to make a distance array whose So what will the size of this distance? 0 to n minus 1 is given, so this will be n. Also we need to find for each and every node to distance to each and every other node, so that would be n. And again, initially all the distance would be int max, because we need to find the minimum, so I'll initialize all with int max, right? Now for reaching to each node, to itself node, suppose we need to go to from 0 to 0, 1 to 1, the distance should be 0, so we will just initialize all the nodes to itself distance as 0, right? As 0, right? Now we have given edges which is representing between 0 to 1, the distance is 3, which is weighted, right? So we will just assign like that. This we will just assign like that, edges, and this is distance of e0, which is source, to e1, which is destination, and this is e2, which is distance, right? So basically this is like source, this is there, or you can write it from to, and this is away, this is distance, right? This is something like that, right? This is something like we have assigned all the initially we have given in the distance threshold. Now what we need to do, we need to find from each node to every other node minimum distance. We will find, we'll find the distance, same thing here which we have written to each and every node, right? We will find the distance from each and every other nodes, right? Just copy like that, right? So for that we need Floyd Warshall algorithm. So first thing is to take an intermediate node, right? We are taking a help of intermediate node. So we are taking help of intermediate node k, and now we will start from I is equals to 0 to n, and also for I is equals j is equals to 0 to j less than n, right? Now this is an intermediate node, and we need to find the distance from I to j, right? From I to j. So we will, what we will do, we will just take distance ij, which will be distance I to k plus distance k to j, right? If I want to find distance ij, I take as an intermediate node k, so that we this would be equal to distance ik plus kj, and we need to this is storing the minimum distance. So what we will do, we will take the minimum between distance ij, yes, right? But one thing, you know that this we have defined as integer, and we have taken this int max, right? So initially it can be possible that distance ik is also int max and distance kj is also int max, so it will give a runtime error, right? So instead of taking int max, we can think, we can take as, see the constants. So see, the distance can be 10 to the power 4, and we have given n is equals to 100, right? So it can maximum go to 10 to the power 6, maximum go to 10 to the power 6. So for safety purpose, I will take only 1 is 7, right? So either if I add both of them, it can be go to 2e max, 2e7, right? Which can, which int can handle, right? So instead of taking int max, I take the maximum value as 1 is 7, right? So this will give me, so now after this we have all the, we have all the minimum distance from each and every other node. Now we will find, need to find the count, right? We will find the count, count of cities we can reach from each other node, right? So for, again we need to start iterating from 0, and again start from 0 equals 0 gen, and now we will need to check that whether distance ij is initially is at most distance threshold or not, right? So if I is not equals to j, right? Because there is no point to see check that, right? I is equals to j, right? Calculate that. So if I is not equal to j and distance of ij is less than equals to this distance threshold, it means we can reach from I to j. So what we will do, we will increase our count, we will increase our count, right? And we need to find the minimum number of count. So for that I will initialize it for int max. Also I need to find an answer node, that would be take as anything you can take. So let's take it as n plus 1, right? Because the maximum answer can be 0 to n, right? Or you can take it as minus 1, whatever you want, right? So but just don't take from 0 to n, excluding 0 to n, right? Just take anything. So this distance is less than, so we will just count plus plus, right? After this, so for ith node, we have calculated all the check all the nodes, that which nodes can be reachable, and we have counted. Now if this count, if this count is greater than the mn, right? If it is greater than mn, so we will just update our count, because we need to find the minimum number of count. So we'll update our count. Also, I will change this I node to I. Okay. Why have I taken equals to? So suppose there are, after this, right? Suppose 0 has the minimum number of count, and I at I is equals to 4, that count is also equals to mn, right? So we need to, if there are multiple such values, we need to return the city with the greatest number. So and I is always increasing, right? So if it is equals to at some point of time, so we will just need to update the answer node, right? That's why I have taken greater than equals to. Understood, right? And just now we will return the answer node, right? So this is how we'll just find the question, find the solution, right? Let's just run this, and we will see the conclusion of this implementation. Okay, something, it's come 5. uh it may, okay, okay, this should be int min, not int max. We need to find, we need to find minimum now. We need to find minimum. Okay, this should be int max. Here, if mn is greater than the count, then we will update, right? This is correct. We need to find the minimum, so mn is greater than this count, so we will update the mn to the lower value, right? That's how it's possible. Done this. Again something, instead of 0 it is coming 4. Why it is wrong? So we have given n plus 1 answer node. uh ij, kj, this is 1 is 7, distance is 0, e0, e1 and e2, right? And this is answer node n plus 1. So count is mn, and this is, so first thing is to distance ii, distance ej. Okay, okay. One thing is that it is given undirected age, right? This is given undirected age. So from distance e to 0 to e1, if this if it is e2 distance, so from e1 to e, from same thing to opposite, right? From to 2 is same, so 2 to from should also be same, right? E1 to 0, this should be also same, right? 2 to from. That's the problem, I think. That this is correct. Now this k is an intermediate between I and j, and this is updating, and this is also updating 0 to 1, right? I think this is correct. Let's try to run this, and this is passed. Let's submit it. Yeah, we have passed all the test cases. So basically what is happening, that that distance between itself node is 0. We have given ages and weight. So from 0, from to 2, if between the nodes, that would be the same for 0 to 1 and 1 to 0, right? From to 2 and 2 to from. That's the problem here, right? And now we have find all the distances, and we have counted the minimum and the maximum, and we have written answer, right? So that's the Floyd Warshall algorithm. Basically the Floyd Warshall algorithm is from here to here, right? This is from here to here. This is the Floyd Warshall algorithm, and this is just a basic logic which we have solved in many questions, right? So this is how we solve this question. Hope it helps. Okay, time and space complexity. So time complexity would be, so you can think of like, we are iterating in ages, then we are iterating in all the nodes three times, 0 to n, 0 to n, 0 to n. So that would be O of nq for sure, right? O of nq for sure. And O of n again, sorry, O of n squared again, and O of n cube, O of ages. So it cannot be greater than O of n cube any number of times, right? So that would be O of n cube. And the space complexity would be, so we have taken a distance array, right? Distance matrix, distance array, a 2D array, and we have not taken any other things other than this, so that would be O of n squared for that, right? O of n squared. So this is how we solve this question using Floyd Warshall algorithm. So Floyd word algorithm just applicable when you need to find all the distances from each and every other node, and the constraints are very low. The constraints are this type of 100, because see, O of n cube can be go to 10 to the power 6 only, right? So if constraints are not low, we can't use this Floyd Warshall algorithm, right? So that's why the constraint should be low, and we need to find for each and every other node. And the basically the thing is that we need to just take the help of intermediate node, such that we can find the distance between I and j, right? Okay, so yeah, that's how we solve this question. One follow-up question for you. One follow-up question for you. You need to tell me. You need to tell me that why I have taken k at first, not at last, or in mediated, right? I can also write na like this, I, and this is I, and like this, right? This also I can write like this, and this should be it, right? Right? Why can't I write like this, and why can't I write like before, right? Before it was k, then I, and then j. So now I am asking that why I can the now the thing is I, j, and k, right? This will give the wrong answer for sure, right? So you need to tell me in the comments that okay, this will give wrong answer, right? Right, this will give wrong answer, right? But why it is giving wrong answer, right? You need to tell me. I'm just correcting it, uh, because I need to paste the link. So right, so you need to tell me that why changing the position of changing the position of I, j, k is giving wrong answer in comments. Just write down any example and you will find out, right? Any example and you will find out, right? You will find out. So thank you so much. Hope you will find this one. Thank you so much. Bye bye.